differentiate y using the chain rule in this example. So take the derivative of the outside part first by using the power rule. Let's bring that 3 down to the front. Keep everything inside this parenthesis exactly the same. We'll deal with this later. And this exponent of 3 will go down to 2. So don't stop there because this is the derivative of the outside part. Now we have to multiply this by the derivative of the inside part. And this is the inside part. So say that you're taking the derivative of x to the 4th plus 2x to the 2nd plus 1. Okay? So the red part, I'm just going to copy this down because I'm done with this. Okay? But now let's work with what comes out of this blue. Okay? Derivative of x to the 4th is 4x cubed plus 2x squared will give us plus 4x, and derivative of 1 is just 0. So that's the final answer. Okay? One more. This one, we're going to have to use product rule. I think I was trying to highlight 2 pieces. So we're multiplying x by the second piece of the multiplication is this green binomial cubed. Okay? So the big plan, the outline is that we will be doing product rule. But I can see that when we differentiate this green highlighted part, we will have to use the chain rule. So I'm going to start by writing down the product rule first, okay? Product rule says that I can find h prime, that's the name of this function, right? By doing first times the derivative of the second plus second times the derivative of the first. Here, first is x, right? This red part. And second is this green part. That's going to be, the green is going to be my g. So derivative of x is 1. Now here we're going to have to use the chain rule. So I write down that g is this green highlighted part, right? I am going to have to take the derivative of this g using chain rule. So take a look. Bring down this 3 to the front first. 3 times x to the 4th minus 4 raised to the 2nd power. Now I am going to find the derivative of the inside part, right? Give me 1 second. Let me raise these arrows. I'm going to find the derivative of the inside part. And that's going to be what? 4x cubed, right? Now, let me multiply this 3 and this 4x cubed and say that my g prime is equal to 12x to the 3rd power times this right here. Ta-da! So I got all my pieces ready. I am going to do the product rule now, okay? So h prime of x, the derivative of the given function is equal to, let's see what first. First times, and f is right there, right? F is x. So I'll say x times derivative of the second. Now that's the one that we spent a long time finding. And that is this right here. You see? I'll write that down. 12x to the 3rd x squared minus 4 squared. Okay? Now, plus sign, right? Plus sign by the product rule. Where's g? G is this right there. So write that down. X to the 4th minus 3 cubed. And the last piece of the puzzle is f prime. and f prime is just 1. So I don't have to multiply by 1, right? Because it's going to be the same. Let me simplify this answer. You notice that I'm multiplying x times x to the third power there, right? So I can say this is going to give me, I'll bring this 12 down, right? 12x to the fourth power. And then I'll bring the rest of it exactly the same. You know what? We can try to factor out x squared, this binomial, because you notice how like we have this binomial here and there, right? They have different exponent, but we can still factor it out to see where we go. But you know, honestly, we can stop there. This looks pretty good. But if you want to continue watching, now I'm about to simplify by, well, not really simplifying. I'm going to try to see if I can make this look any better, okay? By factoring out this highlighted binomial. So how many can I factor out? Well, the greatest common factor will be this binomial squared, right? So what's left inside? If I factor out x squared minus 4 squared, I'm only left with this 12x to the fourth in the first term, and I'll have plus. I will only have one of this left, right? Because I used to have 3 of that parenthesis. I factored out 2. So I just have 1 left. So I'm going to write that down as x to the fourth minus 3. Now I can see that inside I may be able to combine some like terms. This and this are like terms, right? So let's see. This it will be x squared minus 4 squared. I just brought that down exactly the same. But inside the parenthesis, if I combine 12 and 1, that's going to be 13. And I don't know, this looks a little better, I think. This is a binomial times a binomial. So, you know what? I think if you want to continue, factor out and try to see if you can simplify more, that's always good. But the focus of these two examples were how we are using the chain rule to differentiate composition of functions.